Hi there. Sorry, I was just enjoying a wonderful fruit smoothie with the use of this awesome straw. Kind of got me thinking, can you explain to me how a straw and a vacuum cleaner and these things work with just one word? Oh, there's one more thing. The word does not start with the letter S. That's what we're looking for this week. How do those work without using the dreaded S word? So I'm going to do things a little bit differently. This is our last full week of class. We've got 3 videos to watch. I've worked really hard on these. The worksheet goes along with them. Don't try and fill out the worksheet without watching the videos. I'll know that you didn't. Don't quit now on me, guys. You're doing great. The end is in sight. Give full effort. A lot of fun things to learn this week. With that, let's get to the videos. And now, this. Hey, welcome back to science. A friend of mine gave me a challenge the other day, and I thought, ooh, this sounds really easy. Said, all I had to do was set books on my hand. See if I could manage to have 4 science textbooks resting in my hand without any pain. And I had to use this as well. That seemed really easy. Then I was told I wasn't quite doing it right. The idea was to put this on my hand first, and then stack the books on top of that. My parents didn't raise any fools. I'm not going to do that. There is that one brother. I'm not going to do that because, ow. Some of you were probably hoping I would. Some of you were kind of cringing. And some of you might be wondering, gosh, why does that hurt? It's the same weight either way. It's 3 books and 1 needle. What makes the difference? Why does this way hurt when this way doesn't hurt a bit? Well, it comes down to something called pressure. Pressure, for a definition, or excuse me, for an equation, considers both the force and the area that force acts under. So the simplest way to say this is, if you have a force, say the force of these books, and you divide it by a big area, it's going to be a really small pressure. That would be what happened when I set the books directly on my hand. But if we take that same force and divide it by a teeny tiny little area, it's going to end up being a huge amount of pressure. That would be exactly what happens if I were to use this. There are some other places that you are familiar with this from. For one, if you've ever been snowshoeing, you take your force, the force that you're applying to the snow, your weight. When you put on snowshoes, you're dividing by a much bigger area, and therefore you exert a lot smaller pressure on the snow, and you don't sink in quite as much. Another really, really simple example you can do to show this for yourself, you can probably get a family member to help you with this, or you can just do this to yourself. Take a finger, poke yourself in the shoulder. Ouch. Ow. Poke yourself kind of hard enough that it hurts. And then do the same thing, but put a book in between. Just a light book. Doesn't hurt at all, because now that force is being spread out over a larger area. There's a quick definition, quick examples of pressure. Question for you. What units do we use for pressure? Stop the video, take 60 to 90 seconds, write down what you think the units are for pressure. This is the one time I'll actually let you use the common everyday units, the Americanized units for this. It's the one time all year that I don't go metric. Enjoy it while it lasts. You go ahead and write those down. Well, what'd you come up with? If you came up with PSI, or pounds for every square inch, awesome. That's exactly what we're looking for. Pounds is a unit of force. Remember, in our simplified world, a force is simply a push or a pull. And area can be measured in square inchworms, or inches, or whatever the heck those are. I still don't understand them. Square inches. I got one more quick example for you, one more quick question. Now, when I ask this question, I'm kind of picturing Fantasia in my mind. I don't know if you've ever seen that movie. I actually haven't seen it, but I've seen clips of it. I know that there are dancing hippos and dancing elephants wearing tutus. It's very cute. My question is, if you were going to go to a dance and you knew that your partner was going to step on your foot, would you rather dance with an elephant or dance with a teenage girl in spiked high heels, knowing it would only be the spike of the high heel stepping on you? To do this, stop the video and on your whiteboard or in your notebook, draw how big you think the footprint is for that spiked end of the high heel and the elephant footprint. Go ahead and do that now. So this is what students usually come up with. Students usually say that it ends up being a spiked end of a high heel ends up looking about like this. Now I measured it. I grabbed one of my metric rulers, and this other side is blacked out because it's useless, but I could see enough of it that I could see that it's half of an inchworm in diameter, which means that's a radius of 0.25 inches. I actually looked this one up. This is drawn slightly too small. The smallest size foot of an adult elephant that I could find was 12 inches. Believe it or not, I gave it in centimeters. I couldn't find these in inches. The one time that I want to use the useless units is the one time I couldn't find it in there. Oh well. 30 centimeters or 12 inches is the smallest that I could find. That's a radius then of 6 inches. Do you remember your equation to find area? Write that down now. If you said its area is pi times the radius squared, awesome. Your math teacher is very proud of you. Using that, we can find that the area of this spiked high heel is around 0.19 square inchworms, whereas the area of that elephant foot is around 113 square inchworms. So that brings us to this. Well, we need to have some forces. Teenage girl, let's go with 120 pounds. An elephant, let's go with 10,000 pounds. Sounds like, man, that's going to hurt. But let's keep doing this. We said that pressure is the force divided by the area. Grab a calculator if you want and see what these work out to be. Turns out the pressure the elephant exerts by its foot, this is assuming that all their weight is on one foot, is around 88 pounds on every square inch. The girl, on the other hand, when you divide 120 by the actual number. It turns out the pressure on that spiked heel is around 611 psi. To be clear, this means that the pressure exerted by a 120-pound person on the spiked end of a high heel is approximately 7 times the pressure exerted by an elephant standing on just 1 foot. That, my friends, is crazy. So ask yourself, who would you rather dance with if you know that they're clumsy and they're going to step on your feet? This should help you with your homework. And this ends the first video in our series. See you tomorrow.